Hi everyone. In this video we're going to talk about elastic load balancing in AWS and the different options we have. So first of all, what is elastic load balancing or a load balancer for that matter? So a load balancer can automatically distribute incoming application traffic across multiple targets, which can be your EC2 instances, Lambda functions, your containers, or even IP address. And the load balancer can also distribute traffic in a single availability zone or across multiple availability zones also. So this makes it a very good candidate if you want to achieve high availability in your application. So you can have your instances running in across different availability zones. So some instance in maybe in US East 1, some in US East 2. And you can have a load balancer sitting in front of them, which can be used to redirect traffic to both of those availability zones. So in that case, like even if one of your availability zones goes down, so your elastic load balancer can still work on serving up your application traffic using different availability zones. And one good thing is it also provides a single point of access for your application. So you have multiple instances, each will have different IP address. But from a user perspective, they just need to know the IP address of the elastic load balancer using which all the application can be accessed. And it also does health checks to determine what's the health of your instances, whether they are working, whether they are disabled, or they have some error in them. And if some instance fails the health checks, then the load balancer won't redirect traffic to that instance. And some features of it also includes SSL termination. So it also has support for sticky sessions, and some load balancers can support content or path-based routing. So in AWS, like you have 4 type of load balancers. You have the classic load balancer, you have the application load balancer, the network load balancer, and the gateway load balancer. So let's see how a load balancer works. So suppose in the scenario you see right now, you have like 2 instances which are running in availability zone 1, and you have 2 instances which are running in availabilities in zone 2. And you have an elastic load balancer, maybe application load balancer for these examples, say sitting in front of these instances. So suppose when a user 1 comes, tries to access your application, so they will send a request to the load balancer through the load balancer URL. And then the load balancer will direct traffic to, suppose, instance 1, which is present in AZ1. And suppose a user 2 comes and it hits the load balancer, then the load balancer might redirect user to another instance which is present in availability zone 2. And then suppose a user 3 comes, tries to access your application, he might go to another instance which is present in availability zone 1. So in this way, like your load balancer will redirect traffic across different instances in different availability zones. So and it also makes sure like none of your instances are being overburdened and all. So it will equally distribute traffic among different instances. And so let's quickly take a look at type of load balancers. So like we have the classic load balancer. So classic load balancer is an old generation of load balancer which was initially first introduced by Amazon in around 2009, and it supports HTTP, HTTPS and TCP, but it's more of a legacy thing now. So Amazon doesn't recommend using it, and instead of it you can go to application load balancer, which is a newer version of the classic load balancer. So basically, application load balancer is typically used like when you want to support HTTP and HTTPS traffic, and it works on the layer 7 of the OSI model, mainly the application layer. And some features it provides, like it can do content based routing. So like based on the path of the URL, it can redirect traffic to different target groups or different instances. So you can use a single load balancer to redirect traffic to different applications based on what is there in the path headers, what is there in the query string and all. And then you have the network load balancer. So a network load balancer, it basically works on the layer 4 of the OSI model, which is the network or the TCP layer. And it supports TCP, TLS and UDP traffic, and it's extremely fast. So it can handle around millions of requests per second. And then we have the gateway load balancer. So this gateway load balancer was launched very recently. It was announced somewhere around November 2020. And basically it's used to like deploy, scale and manage virtual appliances or firewalls, intrusion detection systems and all, which are like provided by your third party vendors. and it also operates at layer 3 of the OSI model. Okay, so gateway load balancer we won't be covering in great detail in any of the lectures that it is newly introduced. So okay, let's head over to the AWS console right now, and let's see how to create an application load balancer. So I'm in the AWS console now. So for creating a load balancer, we go to EC2, and in the left hand side you'll find load balancing and load balancers here. But before we do that, let's quickly create a few EC2 instances to which our load balancer will point to. So just launch an instance quickly. Select Linux to AMI. Type PT2 micro. So for subnet, for this one I'm selecting US East 1A. I keep the rest of the settings as default, and in the user data I'm going to just paste some code. So what this code is doing is it is just updating the packages and installing the Apache server, and we are just creating a file which is just going to print out the host name when we visit that website. So keep the storage as default, and for this I'll create a new security group. Just name it my security group, and I'll allow HTTP traffic from port 80 on from all the IP address. I just click and launch the same. I'll select an existing key pair which I already have. Similarly, I'll create a few more instances. This time I'll launch it in US subnet East 1B. Is the user rate. I use this the security group which I created last time. Just click continue and launch. So let's create a third one in US East 1C. Let's see what's the status of the instances. These are all getting initialized, so let's just pause for a few minutes. So all three instances are now running and the status checks have passed. Let's quickly just access these instances. So just copy the public IPv4 address and paste it. So I can see it's correctly displaying the index.html page with the private IP of that instance. Simply let's check for others too as well. Okay, so our instances are now ready. So let's create a load balancer now. So go to load balancers and click on create load balancer. So as you saw, we have 4 different type of options available here: the application, network, gateway, and the classic one. So for this one, we'll take a look at how to create an application load balancer. So I just click on create, just name in my demo LB, and here I'll just select internet facing. So load balancers can be 2 type. It could be an internal facing or it could be an internet facing. So internal facing, they won't have a public IP address, so it won't be accessible directly to the internet. So just select internet facing here. IP address type, I'll select IPv4. For listener, I'm selecting HTTP on port 80. If I want, I can add additional listeners on for HTTPS also, but for this demo I'll just keep it as port 80. For availability zone, I'll just select this load balancer to work on US East 1A, 1B and 1C, but I have an option. If I want to select more as part of that VPC, I can select almost all of them. For add-on services, I just won't check it. It's asking me to create an accelerator to get a static IP, those things. I won't assign any tags right now. So when you click on next, you'll get some warning here. So just ignore this and go to configure security groups. So for load balancer, I'll just create a new security group. So this one security group, if it allow HTTP traffic on port 80 from anywhere, just name it my base security group. So now I have to define a target group. So a target group is sort of like a group of instances to which my load balancer will redirect the traffic. So I don't have any existing target group, so I'll just create a new target group. I'll say my group, and the target type in this case will be instance, because we are pointing to an EC2 instance, not an IP or a lambda function, but we have additional options if we want to select a lambda or an IP address. So for protocol, I'll keep it as HTTP, port as 80, protocol version will be HTTP1 by default, and here I can specify the health check settings. So for health check, the protocol will be HTTP, and I'll just say to for checking the health, just go to index.html file, and in the advanced health check settings, you can see the threshold values, what is the timeout and the interval. So for this one, let's just take the interval to 10 seconds. So interval is the time between health checks between different targets. So for this demo, I'm just keeping it as 10 seconds now. And here I've been saying, okay, if the health check passed, only if I get a 200 OK response from the web server. The next one, I have to register some targets against this target group. So if you see, these are our 3 EC2 instances we created earlier. So we just select all of them, and all of them are in different availability zones. I'll click on add to registered, and then index, I just have to review all the settings I selected, and then I'll click on create. So it has started creating my load balancers. So once I go back to the page, you'll see the state of the load balancer is in provisioning. So let's just give it a few minutes. So my load balancer is now in active state, it has been provisioned, and if you see, for the listeners, I have a listener listening at port 80, and you have monitoring also. And if I go to my target group and go on the targets tab, so if you see, we have all these instances that are registered as part of this target group, and the status is now showing it as healthy. That means it has passed the health checks. So unless the status shows as healthy, your load balancer is not going to redirect traffic to those instances. So now let's access the load balancer URL. So I just copy the DNS name, paste it. So now you can see it is correctly hitting one of our instances. It's showing the private IP of that instance. So I just refresh, and you see the address is changing. So that means it is now it has hit another EC2 instance. So if I refresh again, the instance has changed. So it is equally redirecting your traffic to different instances. And just to show you the health check part, so suppose go back to EC2 dashboard. So this is my instance running in USD East 1A. So it has an private IP of 33.254. So what I'll do is I'll just stop this instance now. So stopping this instance will cause the health check to fail, and then let's see what happens. I'm going back to the target group. So now if you see that instance is unused, it's in a stopped state. So when I click on refresh, if you see, my URL is still functional, but I'm not hitting that stopped EC2 instance now. So load balancer has detected that EC2 instance is stopped. It's not in a healthy state, so it is not redirecting any traffic to it. So it's a good way for your application to be highly available even if one of your instance goes down. And I just cover one more point from a security perspective. So if you saw when we created our load balancer, so in this one we gave it a security group. So, and a security group allowed traffic to come from anywhere. So now what I'll do is, for if you see the security group of the EC2 instance, so this is my security group. So it is allowing HTTP traffic from anywhere. So good security practice is ki our EC2 instance, they should not be accessible directly. So what I can do is I just edit this inbound rule. Okay, and let me just delete this rule and I'll add a new rule which will allow all traffic, but in the source I'll keep it as custom, and I'll just give the security group of my load balancer. So that means it is saying this instance is going to accept connections coming through the load balancer now, but directly I won't be able to access it. So let me just save this. So now if I try to access any EC2 URL directory, so now it will just keep on rotating and eventually it will time out because we have stopped direct access to this instance. But if I go to my load balancer URL and click refresh, you can see it is still working and is still able to point to that URL. So the EC2 instance is now accepting connection through our load balancer, not directly. And from a user perspective, so I have only one URL which I can tell my users, so it's a single point of entry to my application. So that's all from my side. So just remember to delete your load balancer and delete your EC2 instance as well once you are done with the demo. And in my future lectures, I'll cover some more details on the application load balancer, like sticky sessions or path-based, content-based routing. So if you have any questions, just drop them in the comment section. Thank you for watching.